Welcome back to our next Algebra 2 lesson, 1.2, Relations and Functions. Let's go ahead and get started. So a relation is a comparison of two or more sets of values. I can basically make a relation out of anything, okay, as long as it's two or more sets of values. A relation is a function. A relation is a function in which one input, my x number, corresponds with one and only one output, my y value number, okay? One x goes with one y. I can't have an x having two different y's, okay? That's going to be my clue that I do have a function. So every x has only one y and only one y. Okay, so in example 1, we're going to go ahead and provide the domain and range. So we're going to go back from the very first lesson. Domain is my x, range is my y, and we're going to identify each relation as a function or not a function and explain why. We'll do the explaining verbally, but if you are choosing to take notes, I would maybe write down why it is a function or why it is not a function, but we will do the explanation verbally. Okay, so I've got a couple of these. Let's go ahead and get started with just a bunch of ordered pairs. So here's my ordered pairs: 2, 4, 4, 6, 6, 8, 3, 4, 5, 7, 8, 2. Remember, in my ordered pairs, I have an x value and a y value. So this is x, this is y. Every time, I never see an x with an x or a y with a y. I always have an x with a y. And the x is always first and the y is always second. So I can go through and I can just put underneath each one x comma y, x comma y, x comma y. You may remember back from Algebra 1, you saw different things like you could talk about x1, y1, x2, y2, x3, y3. Remember, that's just showing that this x goes with that y, and this x goes with this y, and this one with that one. That's the purposes of the ones and the twos. So, and remember, an x1 will always go with a y1. It will never go with a y2. But we will get to that later. Okay, so my domain. And lots of times when you're asked to find the domain, you simply have to put a big capital D and then a couple of dots. Because it's ordered pairs, I'm going to start with my squiggly bracket as best as I can, and I'm going to list all of the x values in order from the smallest x to the largest x. So I kind of have to be careful because I notice there's a 2 first, but then a 4, and there's a 3 over here. So I really need to be careful that I put 2, 3, 4. So I have 2, 3, 4. Is there a 5? Yes. 5. Is there a 6? Yes. There's one more, 8. There's no 7. So I just skip it. There we go. There is our domain. In order, smallest first to largest, commas in between so that we know that these are the 1, 2, 3, 4, 5, 6 of them. Right? Yes. Okay. Now let's go ahead and do the range. Same way to do the range. Start with my squiggle. I'm going to put them in order from smallest to largest. So now I'm looking at the second ones, the y's. I see a 4, I see a 6, I see an 8, I see a 4, a 7, and a 2. 2's got to go first. Then 4. Now there were yes, there's 2 4s. Do I have to put both of them? No. I'm only going to put one. All I'm doing is listing it. I'm not saying, yeah, there's 2 4s. You don't need to do that. Then the next smallest would be 6, then 7, then 8, end with our squiggle. So our range has one less because the 4 repeats itself. Is this a function? Yes, because each x has its own y. This x isn't going to two different y's. This x isn't going to two different y's. So everybody goes to its own. This is a function. Each x has its own y. No x has a double y. Okay? All right, another way you might see a function is in a mapping. So there's a mapping, and you might remember seeing these in Algebra 1. Remember, this is your x, the first circle, and the second one is your y. Okay, so the domain would be A, B, and C. My domain would be A, B, and C. I'll put that over here. Domain A, comma, B, comma, C. And my range would be this one, A, comma, B, comma, C, comma, D. Is this a function? Is this a function? No, this is not a function. Well, why is this not a function, Miss? It looks like a function. All those arrows are going from one letter over here to one letter over here. Yes, but look at that. You can't have that in x. X cannot repeat. I can have that over here in y. That's fine. I could have one letter in y. That's okay. But when I get a repeat in x, that's not okay. Okay? So when I'm asking if it's a function, it's x that you're looking at. Is there a repeat of the x number? Y can repeat all it wants. X cannot. So let's take a look at this one. I'm not going to do the domain and range for this one because I'm running out of space, one, and there are all these funky symbols, just to show you that a mapping can just be symbols. So take a look at your x's. Do any of the x's repeat? Do any of the symbols in this x circle look the same? No, they don't. So this is a function. And my domain and range, it looks like is the same, would be these four symbols. My domain and range would be these four symbols. Okay? All right. Two last ones. Two more. Let me move my page here. Here's the next one. So I have another set of ordered pairs, but in my ordered pairs are names. So this is going to make it a little bit trickier. So be careful. Remember, when you're deciding, is this a function or not, you're looking at x. So you want to look at all these x's. I'm going to put it up here. And you're looking for that x to not repeat. So you cannot see the same name. So if you were to write down the domain for this one, because we have the space, you would write Jim, comma, Joe, comma, Brian, comma, Jim again. Do I have to write him again? No, I do not. And then I would end with Ken. Range. I would come in with my Y's. Alice. Alice again. That's okay. I just don't have to write it. Just don't write it. That's okay. If it repeats, just don't write it. Betty. Kitty. And Nisa. All right, so there's my domain and range. Is this a function? Well, who do I look at? I look at the domain. And I need to go back because right here I'm going to say yes because I see four different names. But remember, there's 1, 2, 3, 4, 5 different ordered pairs up here. And so one of the names is repeating, and it's Jim. Jim is repeating. This is not a function. And it's not a function because of Jim. This is not a function because of Alice. That's okay. It could have been Jim and Alice, Joe and Alice, Brian and Alice, another Jim and Jim and Kitty, and Ken and Alice. That's fine. There could be 1, 2, 3, 4 different Alices. I know of a couple different Alices. So they could be different people. But right here, because I have Jim and Jim, I don't know how to discriminate, or how to discern between Jim and Alice. Not discriminate, discern. How to tell between Jim and Alice and Jim and Kitty. So this is not a function. This is simply a relation. Okay, so how do I figure out if a graph is a function? How do I figure out if a graph is a function? Now, we're going to talk about how to do domain and range on this in later lessons, but we could use our interval notation, or we could use our set builder notation. But to do that, I would have to have numbers on the x and y axis. So right now, we're just going to talk about, is this a function? And the easiest way when you have a graph, and I gave you 2 of them, is to do what's called the vertical line test. So you can do it with a pen or a pencil. I'm going to do it and actually create the line and my ruler. So basically, I'm going to take my ruler and I'm going to put it in the vertical position, not the horizontal. Put it in the vertical position, and I'm going to simply kind of sweep it over my graph. And what I'm looking at as I sweep it over my graph is it ever going to touch the graph in more than one spot? And even though I know it looks like it's not over here, remember, or that it would, remember, it's really, as you zoom in on this, it curves and curves and curves, right? So this one, anywhere I put it, my vertical line, it's only going to touch the graph once. This is a function. This is a function. Remember, as I zoom in on these curves that appear to be vertical in my freehand drawing, they're truly not vertical. They still have that curved shape to them. They're still curving, okay? All right, same thing over here. If I put it up, it's going to touch here and here. It's going to touch here and here. It's going to touch here and here. So anywhere that I put my ruler down and create my vertical line, notice it's touching the graph there and it's touching the graph there. Because I have 2 touches of my vertical line, this is not a function. Okay, so the vertical line test says you have a function when a vertical line touches the graph in only one spot. Just imagine moving that line with your mind. Function. If it touches in more than one place as you move it, not a function. That's what the vertical line test says. Okay? I'm going to put down on the bottom, vertical line test, and it fails it. It fails the vertical line test. Okay, the last thing we need to talk about is how to evaluate a function. And when you evaluate a function, you simply replace or substitute the function's variable with the indicated number or expression. You're going to simply substitute, replace the function's variable, that's the letter, with the indicated number or expression. Okay, let me go ahead and turn the page. Here we go. So this is my last example, example 2. Notice there is an A, which means there's a B part. The B part I'm going to leave for you to do is your bell ringer. So I'll kind of help a little bit, get it set up, but it's going to be your next bell ringer. So here we go. Here is my function, f of x. We've seen this before in Algebra 1. Remember, f of x is how we read it, and this is just a fancy y. This is really just my y, right? Y equals 3x minus 4. So here is my equation. I'm going to put a box around it. This is what I am going to do my substituting into. For f of 0, notice the 0 is taking the replacement of the x. So I'm going to replace the x's on the other side of my equation with the number 0. X of negative 2, replace the X with a negative 2, and X of negative 4, replace the X with a negative 4. So I have 3 problems to do, and I'm going to do them right here. F of 0 equals 3 times 0 minus 4. Well, that's 3 times 0 minus 4. F of 0 equals negative 4. You can just plug it into a calculator. 3 times 0 minus 4. I did it in my head because I don't have my calculator with me. Okay, let's try F of negative 2. So I'm going to take 3x minus 4 and I'm going to replace the x with the negative 2 that it was replaced with on this side. So 3 times negative 2 is negative 6. Negative 6 minus 4 gives me negative 10. Once again, you can plug it right into a calculator if you have one. You could even plug that into your phone's calculator. 3 times negative 2 minus 4. Okay, last one, F of negative 4. So 3 times negative 4 minus 4. I'm just coming right back here to my equation, and I'm replacing the x's with the negative 4. 3 times negative 4 is negative 12. Negative 12 minus 4 is negative 16. There's my 3 answers. All right, so for your bell ringer, your warm-up for next class, there it is. And I said I was going to help you a little bit on the video, so I'm going to help you just a teeny tiny little bit. Remember, you're going to evaluate this function for the numbers 0, half, and 5. So you're going to do for me f of 0 equals 5 times 0 squared minus 2 times 0 plus 1. And you're going to tell me what that number equals. You could change the half to 0.5. 5 times 0.5 squared minus 2 times 0.5 plus 1 equals, and you can tell me what that is. Okay, so this is what your assignment's going to be. I'm going to go ahead and put the other 2 simply because I know some of you will be like, oh, I didn't know we had to do all of them. Yes, you have to do all of them. They're all going to show up for you on the next bell ringer. Okay, so I'm going to finish that up, and I will see you guys next time. There you go. Bye.